What we're going to talk today about is after worlds collide, SIS meets the DCS at our Lake Charles facility. Just to give you a little background on After Worlds Collide. I want you to know it's the sequel and it's the happy ending one. The guy gets the girl, and actually the first baby is born after the collision of Earth with another planet. So it's good stuff. We go to the next one, please. Or I'm doing the next one, aren't I? Maybe. Okay, Axiall. Axiall was actually born on January 26th of 2013, so we've been at it for a little more than a year. It's a merger of Georgia Gulf and the commodity chemical business of PPG is where I came out of. You can read the rest. One good thing about doing presentations, it makes you do research. I thought it was great that we were the world's largest producer of a spice, but then I figured out and did Wikipedia and figured out cumene and cumin are two different things. So, but we are the world's largest producer there, and I know a lot more about it now since I've done this presentation. So enough about our company. I actually want to talk about myself for a second, if you don't mind. I just want you. This is my first ARC conference. I think it's been wonderful. I came here talking about the cloud. We're talking about the Internet of Things, and they asked me to speak about the interconnection between DCS and SIS, and it's like a disconnect. In a way, to me, I'm going to tell you what some of the few things that we've done. I almost bristle at the thoughts of some of the thoughts of interconnection, and so I'm just letting you know, though, that opposed to that, I mean, as a manager, people were talking yesterday about being conservative. I guess I consider what we do at Axiall, we've been conservative progressives. I mean, I just want you to know, coming from a facility that uses lots of wireless, we virtualized our information servers. We're going to have 4 control rooms with high-performance graphics. But when it comes to SIS, and I'm just saying, it's I guess I got lots of gray hair, and I'm a codger when it comes to when you're talking about this kind of stuff. So I'll show you what we did. I think the interesting thing in the future, after I'm done talking, is talk about whether people see things going, and we'll go from there. I have been around for a few years, and there was a time where it seemed like we had a screen for everything in the control room. It was on different screens. The vibration monitor was over here. The DCS couldn't start a pump, so we did it over here on a PLC screen. Just had screens for everything, and there came this. Thou shalt provide this single window out into the operation for the operator, which I sort of grew up in and embraced. And then on the other side, you have this. You shall keep the SIS system totally separate. And the question is, where do you let the interconnection come in? The one place that we, I guess, have done that is on the human-machine interface. This is typical of what we do on the DCS. We've made everything dynamic. Coming from the SIS. Of course, we show the values. I mean, that's pretty straight. We show the trip settings actually down in the SIS system. Years ago, we used to actually just made them static, and trip settings would change, and so it just seemed you can do it. Let's get the actual value that's down there. We actually show the voting. If we have a 2 out of 3 and we bypass it, we actually vote it in. So actually the voting will show what the bypass is doing, and also the time delay. So we try to make everything alive, and so it's actually the operator has actually what's down in the system. Okay, the good. One good thing we had, I really like our bypass procedure that's sort of developed. And I really think, actually, if I go back real quick, service status normal, we do allow bypassing from the DCS, which a lot of people would go, no way. But I'm going to go through our procedure, and I think we have something in there that sort of adds a layer of protection there. But we did have one, I think, good thing come out of the fact that it was in the DCS, and it made something very, so we could notice it. And I said, oh. So the good is our bypass procedure. The nice thing about DCS is that it has a lot more built-in action journals. It captures everything what the operator does very easily. We decided years ago to capture all our trips, so when we did revalidation, we know why a trip, we know frequencies. That would help out. At the time, we said, let's capture the bypasses. Didn't have any plans for them, but it just seemed like a piece of information to have. We went back, I think we've been actually capturing for a couple of years, and we saw something. It was bad. We saw some bypasses that shouldn't be happening. I guess you take into, I guess you have this belief that everything is fine. We had a procedure, we had paperwork, but yet, it wasn't like frequent, but we caught a couple things that should never, ever happen in a chemical plant. It was all born out of getting this data. So I'm going to kind of go through what we do with bypasses these days. We do allow bypassing from the DCS, but we still make it be a key enable. So you can't go to the screen and just bypass something without first getting the key, putting the key into the panel, and then from there, you're allowed to bypass. The other thing we do, though, is we only let you bypass one instrument, with the only exception being analyzers, because we run into a problem that sometimes they have common sample headers. So you got to key it. You only get one instrument. If things are going awry and you would have to do two, then it's time to shut down, because we don't want to degrade our system to that point. We do not allow bypasses or unbypassing in a trip. Just a little extra, I guess, programming feature that we have employed. Requires a form. It's got to be signed by a supervisor. It's got to, the operator's got a review, and he actually has to write down what the SOEs are for the thing he's going to bypass, and then we got to write down what are we going to do while we have this bypass to compensate for it not being bypassed, or for it not being in service. And the other thing we do is the next morning, anything that gets bypassed, the team leader of that area will get an email letting him know a bypass occurred in his area. And he's got to reply to that email saying that he acknowledges and it was what I would call a good, clean bypass. Been monitoring this for years now. It's real easy to kind of tell what I would call a bypass you don't want to see. A lot of times they happen at 2 in the morning. Not many people out doing proof testing on instruments at that time. From what I can see and look at the data now, I get a monthly report. All our bypasses are done right, they're done legit, and they're done for the right purpose. Another thing we've done that's been very helpful is for those who've grown up in the rheostat, we actually now do our simulation for fat tests using our DCS. And so we just let it push registers into, or values into registers and do all our checkouts this way. it's been really good because it also allows us to bring the operators in who are used to using the DCS, and they can play with it themselves. We've got some other screens that can get you into other scenarios so they can actually do the checkout themselves. We are very cautious of the fact that, okay, here you really are writing to an SIS, but there's a package part of the program that is, we only do this offline in this shop, and there's part of this simulate program that we don't put out in the PLC in the field, so it can't be activated. And even if somehow it did, we have tested it 150 ways to make sure there's no way that on a live system that you could get into this mode. And it really has saved us, of course, a lot of time from the panel board, and it's cost effective, and it's also doesn't require any additional training in people. Next thing I want to talk about is the must. How we treat an SIS different than a DCS. I mean, with our SIS, what we'll do is we'll allow one point-to-point communication between the SIS and the DCS. We have two SISs sitting out there next to each other. We won't put them both together and bring them in network. Just one-on-one, so we know exactly what we're dealing with. Our management changes. I mean, I think we have a very great management change for everything we do in controls. But when you get into, I'm going to change something in SIS, we're looking at ORC approval, which another three-letter thing, but that's our Operations Review Committee. And so we get people, from outside the department to look what we're going to do and make sure there's not anything we're missing. If we're going to change something in a SIS program, we do a full acceptance test. Doesn't matter. If we're changing logic, we're going to test it top to bottom. Some cases, our worst case, that would take 2 days. A lot of times it's a half day, but whatever it takes, the software that's going to be running out there in the SIS is going to be the software we tested, no matter what. Register changes. I've been the manager now for 13, 14 years. Twice we've made some temporary register changes, and that was actually because of some piping it degraded. We had to lower the pressure rating on it, so we actually had to bring a set point down on an SIS. And so, twice we have made register changes online, but we do a temporary MOC. We get the whole world to sign off on it, and we get 2 sets of eyes on it. We do it in the shop. We make sure we got it right, and then we take it out in the field. Which brings me to culture. To me, that's the thing about an SIS. I was standing over there, and I used the word worship, and I was told that's probably a bad word. But to me, you got to put the SIS on this pedestal, and it has to be treated differently than anything else you do in process control. It is the one thing you have got to be able to count on. And so the culture around that thing has got to be, it's got to be Oz. You got to feel privileged to go up to it. You really got to treat it like that. So, our manufacturer and other manufacturers I know have already done this. Is the SIS, the DCS on a common communication network, SIS and DCS on a common engineering platform. I truly believe that no manufacturer is going to do something that's going to cause a common mode of failure, which is the big test when you're looking at SIS and DCS. And by doing what they're doing, I know what my vendor is doing, and they are not violating that rule whatsoever, and I don't think anybody else is. But even here, I worry about culture. I worry about the engineer who now can, configure the DCS, now from the same wrapper can go in there and configure the SIS. To me, it's a slippery slope. In itself, there's nothing wrong with it. However, it just seems to me, I mean, just culture-wise, you got to keep it separate. And I know, big refineries, and my plant happens to be a very large plant. I don't really think we'll have a problem, but I kind of worry about, and I see it as, I actually have managerial oversight duties at all our chemical facilities. And you get these, we have little one-man plants, that guy takes care of the control system, he takes care of the instruments, he takes care of, and he is not as well versed and diversified in knowledge as we may be at the bigger facilities. And I just worry that maintaining that culture is going to get more difficult as you start integrating these tools and platforms. Another thing I just wanted to throw out, integration with procedural automation. And I don't, at this time, know a lot about procedural automation. I think there's a talk next session, so I hope to know more about it. But been in the business, this will be year 34. Most, and believe it or not, we've had a couple events in those years. Almost everything that's ever happened, and I try to rack my brain, has always been during a startup or a shutdown. We're running along normally, and not that an SIS has never kicked in and tripped us, but we have never had a failure on demand of an SIS. But we have had incidents on startup, and we've had incidents on shutdown. And my precursor, or understanding of procedural automation, is its big strength is in those startup and shutdowns. And so somehow I think there is this possibility for some sort of integration there, because I don't know what other people do, but generally speaking, when we start up, we have to bypass a lot of our interlocks because you can't, you have a low flow trip. Well, you can't get started with a low flow trip. It just seems to me that with procedural automation, and the DCS has got a lot more variables and a lot more things that it can look at. Whether there isn't, and I realize tying them together, I don't know. Just food for, actually it's my food for my thought, I guess, but one of the things I've been trying to educate myself on is procedural automation, and I just see that maybe there's a future tie when you get into startup and shutdown mode, because that's a lot of times where the permissives that you had no longer apply. And that's my talk. Thank you.